All right. So what we're going to look at now, we're going to look at exponential equations and logarithmic equations. And there's two problem-solving skills that are going to help with this. Remember that for the base b, it's greater than 0, and b is not equal to 1. And this is going to be true for both exponent functions and for log base functions. So one of the tricks we're going to use is this. If b to the m equals b to the n, then m equals n. So since the bases are the same, the m and the n are going to be the same. And again, this is when b is greater than 0, and that means it's not equal to 0, and b is not equal to 1. Also, if we have this, then this means m, again, is equal to n. So, using these two facts and some other skills we've learned so far, we're going to solve these equations. So first one, 2 to the x equals 64. Now, what if we could turn this into an exponential expression with a base 2 and an exponent? Well, we can. It turns out that 64 is 2 to the 6th, or 2 to the 3rd times 2 to the 3rd. 2 to the 3rd is 8. So the bases are the same. That means the exponents are going to be the same. And so x is 6. Now, throughout these problems, I'm just going to go through them. And typically what you want to do is you want to check your results. Now, for a couple of these, I'll check the results. But you should check just in case. Anyway. Now, let's say we have something like this. Again, can we make this into an exponent expression where you have a base 5 and some exponent? And it turns out you can. So since the bases are the same, we can equate what's in the exponent spot. So we get 3x minus 1 is equal to 3. Now add 1 to both sides. 3x equals 4. Divide both sides by 3. X is 4/3. And again, you would want to check this on your own. Make sure it's okay. But this one, let's take a look at it. Yeah, this one's going to be fine. Now, some of these can be a little more subtle. Let's say we have this. Now, what we want to do is convert this square root into an exponent. And a square root is an exponent of a half. So, again, bases are the same. We equate the exponents. We multiply both sides by 6. We'll get x minus 2, and then 6 times a half is 3. Add 2 to both sides. X is 5. And then we can check this, but it's going to work. It'll work out. But you can plug in x is 5 here, simplify, and you'll get 7 to the 1/2, which is the same as square root of 7. Now this one, we want to work our way closer to x. So before we can take the logarithm, make this disappear, or the natural logarithm, gotta get rid of this 5 first. Divide both sides by 5. Now we could do the logarithm. This is a base e, so we want logarithm base e, or the natural log. Take the natural log on both sides. And so that means that cancels. We get x is natural log 23 over 5. And again, you would want to check this, and it does check, it does work. Now what they'll do is they'll sometimes have you approximate this to say a decimal to 2 decimal places. So let me look for a calculator around here. There's one. So natural log 23 divided by 5. It's approximately. So this is a good answer. But in the text, they might want you to do this. Come up with an approximate answer, 1.3, rounding to 2 decimal places. All right. So here's another one. Again, we want to work our way close to x. So we're going to start out here and work our way in. Got to deal with this minus 2. So let's add 2 to both sides. Now we can take the natural log of both sides. We're going to get this. And again, that natural log in the base e, this is log base e. That's a base e exponent expression. They're going to go away. We're left with 5x minus 3 equals the natural log 478. Add 3 to both sides. Put this in parentheses. And then finally, divide both sides by 5. Now, we're always actually doing that when we say this. We're not really dividing 5x. We're dividing the left side, and it just so happens to have only one term. But we're dividing this entire right side. And this one has 2 terms. So the entire right side, both terms are divided by 5. So what that means, our final answer, natural log 10,478 plus 3 over 5. And that does work. Now, how would you check this answer, though, to be fair? Well, here, let me give you the approximation to 2 decimals. So it's approximately 2.45. So how do you check an answer like this? This is really a complicated one. Well, we go through it step by step. So we have E, 5, and this is going to be multiplied to natural log 10,478 plus 3 over 5 minus 3 minus 2, and then equals the 10, 4, 7, 6. Yikes. So this is all an exponent here. Well, these 5s, they're going to cancel. So let me just circle this. This whole piece here is an exponent of e. And then this exponential expression subtracts 2. Supposedly it's equal to this. Hopefully it is. So the 5s here are going to cancel. So we get e natural log 10, 4, 7, 8 plus 3 minus 3. So the 5s cancel, you get this plus this minus that. Subtract 2, and does this equal 10, 4, 7, 6? And again, this whole thing is still the exponent of e. So now, as you can see, the 3s are going to cancel. And so we get e natural log 10, 4, 7, 8 minus 2. Does this equal 10, 4, 7, 6? Well, here e and natural log are going to cancel. Again, they have the same base. So as a result, those go away, and leaving 10, 4, 7, 8, subtracting 2, and sure enough, that equals 10, 4, 7, 6. So it does check. Anyway, just wanted to go through that one, just one of the more tricky ones to check. What I found with these is if you try to check using the rounded number, it doesn't always work. For example, let's see here, the next example, we'll get an approximate answer of 0.09. And I put that into, actually put 0.8089, a little bit more accurate to the answer, and it didn't appear to check. But sure enough, that was the correct rounded answer. It would be 0.09, and the answer is even closer to the real answer, 0.089, and well, we'll see. It doesn't always work when it's a rounded answer. So just something to keep in mind. If you want to check these, you're going to want to use the exact answer. All right. So let's look at that other problem. Actually, 0.09 was closer to the real answer. We'll try it. We'll see if it works. But I'm pretty sure the rounded answer isn't going to cut it. Well, now here we've got a problem. These are two very different bases. So what can we do? Well, we'll take the natural log of both sides, because that'll make these exponents pop down. So we get 2x plus 1. Well, here, let me not get too far ahead. So natural log 7, 2x plus 1 equals natural log 3, x plus 2. So these exponents are going to hop down in front of the log. 2x plus 1, natural log 7 equals x plus 2, natural log 3. Now we got to distribute the natural log 7 and the natural log 3. So we'll distribute this. We'll get 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. And I'm going to subtract x natural log 3 from both sides. This puts all the x terms on one side. You have 2x natural log 7 minus x natural log 3 plus natural log 7 is 2 natural log 3. And now I'm going to subtract natural log 7 from both sides. All right, we've got it. Now we've got the x terms on one side, non-x terms on the other. Let's factor out the x terms. And now we can divide this entire piece on both sides. So we're multiplying that piece to x, the opposite of multiplication is dividing. That'll make things cancel. And again, we're going to divide this entire side by this whole piece. And so this is a pretty good answer right here. We've got it. But we can tighten this up a little bit. Remember, these can act as exponents. So we'll get ln 3 squared minus ln 7 over ln 7 squared minus ln 3. And so that's going to give us natural log, or ln, of 9 minus natural log of 7 over natural log of 49 minus natural log of 3. And so what we get here is the difference of logs will be the log of a ratio. So this means x is natural log 9/7 over natural log 49/3. That's a 3 there. And that's an even, maybe a better answer, more compact. And then finally we can round this. Let's see here. This would be 7ths. Natural log 9/7 divided by natural log 49/3. And you get to 2 decimal places, 0.09. So the thing we need to do is this. Let's try to check it using the approximate answer. Now, this is the correct approximate answer, but we've rounded it. So let's see what the results are. So 7 times, or exponent of 2 times 0.09, plus 1 equals 3.09 plus 2, or 7 to the 1.18. Does this equal 3 to the 2.09? Let me check my arithmetic here. All right. So 7 exponent 1.18 is 9.94. Well, let's take it a couple places, just a few more places. 9361. And this one rounded to fourth decimal place. 9.35. I'm sorry, 9.93, but it's close. 54. So when we use one of these rounded answers, if you try to check with that answer, it's not going to turn out correct, but it's pretty darn close. That probably, maybe that means we're on the right track, maybe not. But if you want to check your answers, you're going to want to use that exact answer. All right, let's look at this one. So what we can do is rewrite this as e to the x squared minus 2 e to the x minus 3 equals 0. And then we let u equal e to the x. When we do this u substitution, u squared minus 2u minus 3 is equal to 0. So this makes it a quadratic. We can solve this. I'm going to use factoring. If you use the guess and check method, we'll get u plus 1, u minus 3. Double check that real quick. Yeah. So this means u is minus 1 and u is 3. Now, right away, there's going to be a problem. Recall that e to the x equals u. So that means it's e to the x that equals minus 1 and e to the x that equals 3. If we take the natural log of both sides, well, natural log and e will cancel. So we get x equals natural log negative 1, x equals natural log of 3. Now there's a problem though. We can't take the natural log of a negative number. So that means this is not possible. And so the only answer we have would be x is natural log 3. And just giving it a quick gander here, that is, well, let's check it. Make sure this works. So this one, e to the 2 natural log 3 minus 2e natural log 3 minus 3, does this equal 0? Well, again, we could make this an exponent of a 3. Does this equal 0? Or e to the natural log of 9 minus 2e natural log of 3 minus 3, does that equal 0? So we're going to have some cancellation. E natural log, E natural log. Those go away. And so what we're left with is 9. This was 2 times whatever this is. Well, this is now just 3. Minus 3 equals 0. And this is going to be 0. So sure enough, x natural log 3, that is going to work. All right. So those are some exponential equations. Let's look at some logarithmic equations. So how do we solve this? Well, for this one, we could just use sort of our wheel. Here we go, 4 to the 3 equals x plus 5. We convert it to an exponential equation. So 4 to the 3 equals x plus 5. Now 4 to the 3 is 64. This is x plus 5. Subtract 5 from both sides, and we get 59 equals x. And for the sake of time, I'm going to ask you to check this one on your own, but giving it a quick gander, it does work. It does work. So let's take a look at another one of these. Oh, this one's a little more complicated. Again, some of these are going to get more subtle. So look at this one. Natural log square root x plus 3 equals 1. Now for this, we want to get rid of the natural log. So what we can do is make both sides exponents of e. So ln square root x plus 3 is now an exponent of e, and 1 is now an exponent of e. And so what this does, it lets us cancel that natural log. And so now we have the square root x plus 3 equals, and e to the 1 is just e. Well, to get rid of the square root, we square both sides. That gives x plus 3 on that side, but e squared on that side. Subtract 3 from both sides. E squared minus 3. And just giving it a quick look, that is going to work. So there you go. So sometimes you'll have to take both sides and make them exponents of some base. Well, let's take a look at another. So let's say we have something like this. One thing that'll help is to combine the logs. The sum of logs will be the log of a product. Not the product of logs, but the log of a product. So we get log base 6, x plus 3, x plus 4 is equal to 1. And now what we do is we make both of these exponents of a base 6. Because if there's a base 6 here, the 6 and the log base 6 will cancel. So now we get cancellation. If we FOIL this, subtract 6 from both sides. And then we can solve this quadratic for the values of x. So if we do that, we get, let's see, x plus 6, x plus 1 equals 0. So that means x is -6 and x is -1. Now we definitely want to test these answers. So looking back at the original problem, log base 6, x plus 3 plus log base 6, x plus 4 is 1. Let's try this for -6. Well, what we're going to see, it's not going to work out right away. You're going to see a problem. The problem's going to be this. Log base 6 -3 plus log base 6 -2. Does this equal 1? Well, it doesn't matter. The reason is log of a negative we can't do. So -6, it's not going to happen. So let's try x is -1. Well, does this equal 1? Or is log base 6 of 2 plus log base 6 of 3, does that equal 1? Well, the sum of logs will be the log of a product. So this will be log base 6, 2 times 3. Does that equal 1, or is log base 6 of 6 equal to 1? Well, it is. Log base 6 of 6 is 1. So that tells us we have an answer. X is -1. So one of these answers, even though the algebra worked out fine, one of them doesn't work and one of them does. So again, it's why you want to check your answers. So let's see, I have one more to do. Let's do this one. So log x plus 4 equals log x plus log 4. Now you got to be careful with this, because this looks like there's some kind of general rule here. Like the log of a sum is the sum of the logs. It isn't in general, not in general. The log of a sum is the log, or the sum of logs is usually the log of a product. So this might be a special case. And it's going to be. But just be careful. This generally isn't true. If you have a sum of logs, it'll equal to the log, not of a sum, but of a product. But this might be a special case. So the log of a sum is the log of a product. This is true. And so now what we can do, we can use that principle where we have log of the same base, and again, a log that's plain, where there's no base stated, that usually means log base 10. Now there are some programs, some software, some computer languages where they'll say, well, it's log base E, like the R programming language for statistics. If you use a log function, it assumes log base E. But on scientific calculators, most scientific calculators, this is going to be base 10. So the bases are going to be the same. So that means what's on the inside will be the same. We finally get to use that problem solving technique for logarithms. And again, log base 10, log base 10. That means what's inside, they have to be equal. So we can subtract x from both sides. Divide both sides by 3. And there's the answer. And this answer does check. But you want to make sure to do that anyway on your own. So that's it. Any questions about this? Let me know.